An SN2. Okay. So there is on the problems that I gave, and I like match. You have to match the energy coordinate diagram to the reaction. So my energy coordinate diagrams are going to look like this: one hump, two humps, three humps, and then I would give you a reaction. So let's say I say about CH3Cl plus hydroxide. One. So one hump A. So one of the things we're going to need to know is the chart. So this is what? This is a methyl, primary, I guess. But it's methyl plus strong nucleophile. What mechanism is this? SN2. So it's an SN2 reaction like this. How many intermediates am I going to have? None, because it's going to be straightforward. So that would be reaction coordinate diagram A. Let's say tertiary chloride plus the hydroxide. And it's usually better. It's usually more straightforward to make the assignments based on the number of intermediates. So instead of counting humps, count valleys. So with this reaction, first of all, mechanism SN1. How many intermediates? One. It would have one intermediate. That intermediate would be the carbocation. So this would have one intermediate, which means that it is B with the one intermediate.
Is SN1 always going to have just one intermediate?
Well, let's do the next problem and see. So now I change it to tertiary chloride and water. So this is the mechanism. This is SN1. How many intermediates does this have? Two. Those two intermediates are the carbocation and the oxonium ion that comes from the water adding to the carbocation. Right, this one. So in this case it has two intermediates, so that makes it C. That would have no humps. Actually, if I did a primary and water, it would basically be no reaction, and I'd have to have a D up here that says no reaction, which I could have, depending on. I think there's only a 1, 2, and 3 humps. Reaction coordinate diagram. I don't think there's a fourth one, is there? There's just those three. All right. One more. Because I can then do that with alcohols. And say let's react tertiary-butyl alcohol with HCl. What diagram would fit that mechanism? So again, you would want to think of, okay, what are my intermediates going to be? I'm going to have an oxonium ion from protonating the oxygen with the H plus. Remember, OHs go nowhere as themselves. They must be converted to water. An OR group has to be converted to an alcohol before it will leave. So that would be the first intermediate. Then what would happen next? The water would leave, and I'd end up with a carbocation. So that one would be C as well. That one has two intermediates. And so that one would be C. Okay, so that's a good question. What would happen if I did that with a primary OH? Because I don't think you've seen one of those before. I'm just bringing it down here so I can come down here. Okay, next. I don't know. Let's do this one. Butyl alcohol plus HBr. I will agree. No. I will agree with that too. And they are not. The only thing different about those two answers is the actual answer. So one of them has to be correct, but they are both true statements. This will occur when the BR, or there will be no primary carbocation. True. But I do need to protonate the OH before it can leave. So I would take this OH, I would protonate it to make the oxonium ion, and then the BR minus would come in and add and kick off the water. So in this case, I would have one intermediate. So this would fit reaction coordinate diagram B. Yes, for the moment. Because the only other way to get two humps for an SN2 reaction is to have the nucleophile be a neutral nucleophile that would lead to an oxonium ion. Our halogens are not good leaving groups for that. So yes, you could get that, but not with a halogen leaving group, which is what we've kind of limited ourselves to. So if this was the for that reaction, if I said how many steps will this reaction take, it would be 2. One to form the oxonium ion and one for the bromine to come in and kick off. But you already knew the answer to that. Right? Because HBr is the equivalent of sodium bromide plus H2SO4. I'm not seeing that hint helping anybody. 45-minute reflux. That's what we did in the lab. We just use sodium bromide and sulfuric acid instead of HBr.
So is this like an exception where you can have a primary carbocation?
No, because what we're doing is we're 1, 2, 3, 4. We are protonating the OH group, but it is not leaving. Because if it left, you would get a primary carbocation. Instead, what we're saying is the Br minus is going to come in and kick it off. So it's still going to do SN2. But now what I have to do is I've got to make the OH group leaving group, and the way I do that is by protonating it. So it's still an SN2 reaction. Why? Because it didn't involve a carbocation. Our definition of 1 and 2 can be broadened out. 2, no carbocation, 1 mechanism, carbocation. Oxonium ions don't count for that count. You don't count you only count carbocations, not oxonium ions. So this would be SN2. This would be it would be a different kind of answer because you would get B. Please.
So are good leaving groups like nucleophiles?
Yeah, I would say so. Or they're non-nucleophiles.
Okay.
Yeah, that's the way it should be. Good leaving groups are weak bases. And in general, weak bases are usually weak nucleophiles, depending. So I wouldn't say it that way. I would say it the way I said it, which is weak bases. Because what's Br minus? It's a weak base. It's not even a base, right? Bithrobromine in water, it's not deprotonating water. Because it came from HBr, a strong base, or a strong acid. So Br minus, we'd say, well, that's a weak base, but what kind of nucleophile is it? We consider it to be strong, but the only thing that's strong about it is its negative charge. You compare a Br minus to OH minus. OH minus is a much stronger nucleophile than Br. As a matter of fact, take any halogen and compare it to OH minus, halogen loses in nucleophilicity. But take halogen, compare it to OH in a leaving group or in a leaving group situation, and leaving group wins. Okay. Triple bonds. We are starting in triple bonds in all sections next semester. I just talked to Dr. Dowd about that. And so we are starting with triple bonds. All 3 sections should have covered the same material, but I know I have an assignment in my class for next semester that I will hand out on day 1 covering all of Organic 1, a week's of assignment that you'll have a week to do. So try not to forget let's take first things first. Try not to forget anything until next Wednesday. And then after that, you're going to have to put it all back in here to make it work. Okay. All right. If you have any questions, post them on Piazza or come see me. Otherwise, I'll see you next Wednesday. I'll take your assignment and I'll hand out the exams